What's happening, folks? Geologist Philip Prince got you out in California today, looking out over the Pacific Palisades area. Wanted to talk about the fire disaster that's taking place here right now, and discuss how the mountain landscape around Los Angeles actually contributes to events like this. This, of course, isn't the first one that's ever happened, but it is particularly severe, and it's going to have a lot of impacts that are going to be ongoing for quite some time here. Uh, to put this picture together, you really got to zoom out. You got to think really big, and go beyond even the size of sort of the overall LA area, which is absolutely immense, particularly to an East Coast person like myself, and actually look at the entirety, sort of Western North America, at least the western part of the continental United States, because this is what's going to set the stage for what's happening there in the Los Angeles area. When the air moves in a certain way in that part of California, you can end up with a very hot, dry wind. And that hot, dry wind does a very good job of drying out what's already a very flammable type of vegetation, and setting the stage for the type of fire scenario that you see going on right now. Now, it's sort of hard to think about hot, dry winds going on in a place that is right next to the ocean. We're going to put kind of a yellow dot down here, right over top of that would cover up Pacific Palisades all the way out past Malibu and beyond there. It's right on the Pacific Ocean. Okay, so there's the potential to have a lot of moisture impacting that area, but it's also got a huge expanse of desert inland in the other direction. And that is what is actually coming into play right now. If you get a high pressure weather system situated in just the right spot in Western North America, high pressure weather systems cause the air to move around them in a clockwise fashion. So if we start to illustrate that here, we wipe to contrast with the topography a little bit more. So we start moving that air in a clockwise fashion, it's actually going to be blowing from over here in the dry desert basin and range area down across the San Gabriel Mountains and down into Los Angeles, right? So with this particular weather scenario, you're actually taking air from the dry continental interior and taking it out out towards the ocean. So even though LA and its surroundings are sitting right there in the ocean, under a situation like this, they're actually getting desert air delivered to them. Okay, so that is one pretty significant detail to what's going on right there. Now, if you tuned in to any of the Helene videos I did over the past few months, talked a lot about what happens when air masses interact with mountains. In the case of Helene, had moist air blowing upslope, so it was being pushed to higher elevations by mountain topography, and that was causing it to rain more and more. Now, in this particular case, you actually end up with the exact opposite taking place. All right, so now we've zoomed back in. We've got downtown LA right there. To have Whittier here, Pacific Palisades, where we started out, all the way over towards Malibu area. Again, huge area for an East Coaster. Just the physical scale of this place is absolutely immense, and that goes not only for the city, but also for the mountains right here. And right in the center of the screen, got the San Gabriel mountain range, and this feature is really what takes that desert air blowing from the interior of North America out towards LA and the ocean, and turns it into sort of a totally different thing that can sort of cook and dry out all the vegetation and produce not only a lot of wind, but a very hot, dry wind that makes the fire situation just that much worse, right? So where the hand is hovering over right now, those are really big mountains. The highest peaks here are about 10,000 feet above sea level, on what would be the southeastern end of the San Gabriels. Downtown LA here is just a couple hundred feet above sea level, and of course that slopes off to sea level there at the Pacific Ocean. So there's anywhere from about a mile and a half to nearly 2 miles of elevation difference across those mountains. And when the wind is blowing, out of that interior desert and out towards the ocean, as it comes across the mountains, it has to drop down considerably, as you see here. Again, when you say drop down, it descends about a mile and a half on average, I would say, as drawn right here. The highest elevation it's going across probably 7,500 feet or something like that. And that descent of the air moving downward, that causes it to compress. And when air compresses, it heats up and dries out. If you are type of person that's ever used like a bicycle pump or something like that, you can tell like the bicycle pump gets hot. So compression is a way of actually heating an air mass. And when one has to descend this far, it can warm up quite a bit, 10 or 20 degrees Fahrenheit or something like that. The drying that comes along with that really sets the stage for a hot, dry atmosphere. And because there is wind, there's air moving, and it's moving all this hot, dry air. It is sort of like running, you hear the analogy running a hair dryer on the vegetation or something like that. So, with this, again, particular scenario, you end up with not only a wind that fans flames, but a wind that sets up conditions of atmosphere and humidity that make everything all the more flammable, right? So that is sort of the atmospheric setup there, and it's this descending wind. It's the idea of the air going going down slope and going down slope a considerable distance that produces that heating and drying effect that sort of sets everything up to burn here. All right, so that's sort of stage one in terms of how the shape of the land and particularly where the mountains are uh, sets Los Angeles and its surroundings up for a fire scenario like you see here. Now, if you zoom in a little bit closer, you actually get a sense of what the land itself looks like along the front edge of those mountains. And that's pretty interesting to do because it's really, really, really crazy, incredibly rugged. This particular part of the world, the San Gabriel Mountains along the San Andreas Fault, the uplift of the rock out of the land to make these mountains is exceptionally fast. I mean, this landscape matches up with anywhere on Earth as far as somewhere that active mountain building is continually going on and going on very quickly. And the result of erosion cutting into those rising mountains is really, really, really complex extreme mountain topography. You have all these canyons, like you see here, that cut their way from sort of this plain almost moving down towards Pasadena and Los Angeles. That plain transitions very abruptly here into this really exceptional mountain topography. And you end up with all these canyons, and you can imagine that when the wind is blowing from top right of the screen towards bottom left, it's going to get sort of funneled through these canyons. There's going to be all sorts of turbulence on the backside of these mountains, and the wind can actually get sort of amplified by that process. So not only is it a very hot, dry wind that's drying everything out around it, it's moving, so it's set up to actually push fire around. It's also getting enhanced by the topography to be all the stronger in terms of just the force of the wind, right? So this is a place that the mountains aren't doing it on purpose, but just the fact that they're there and they're big uh, really presents a an atmospheric setup, and we're talking about lower atmosphere here, basically ground level air masses, that is sort of tailor made to set the stage for a pretty exceptional fire event. Now, on top of that, the vegetation that grows here along the front of these mountains is used to being in sort of a drier climate. It tends to be sort of like an oily or almost waxy leaf type of vegetation. It burns really, really well when it gets dried out. In fact, it burns better than, say just a regular hardwood tree on the East Coast. And fire is actually a part of what the landscape experiences here to renew vegetation. It's just sort of a thing that's going to happen anyway. The issues start, of course, when people are trying to live here and interact with such a challenging landscape that's going to be dynamic whether people are there or not. Now, what it really comes down to again is this sudden change from crazy high rugged mountains down to this almost flat plain at the base. And that is something that you see in a lot of locations here. Of course, at the foot of the San Gabriels, there again, kind of east or northeast of Pasadena. It's at its most extreme, but over here in the Santa Monica Mountains, above Malibu, you see sort of a similar pattern. Even out here in Whittier, you've got sort of an abrupt rise of some small mountains off of this what's otherwise kind of like a flat plain landscape. Why does this happen? What's the setup here? Actually, it all comes back to plate tectonics, San Andreas Fault, the fact that there are also really big earthquakes in this area. It seems like every time you hear about California, there's some kind of crazy natural disaster going on. Good reason for that. And I'm going to draw out really quickly in a simple diagram why these mountains are so big, what the San Andreas Fault has to do with them, and also why the front of them is so sort of abrupt like this to allow that wind to flow across them, drop down thousands of feet, heat up, dry out, and just turn this place into sort of a tinderbox, right? So hang on just a minute. Okay, so how does plate tectonics impact sort of the overall natural disaster scenario in Southern California? Classic place to cook up a block diagram right here. And of course, this is a part of the world where quite a few block diagrams have been done to illustrate these very ideas over the years. So what I got here is kind of our block of the Earth's crust there, but it's broken down the middle. That's gonna be our San Andreas Fault, right? And we're gonna move this side of it in that direction and keep the right side of it there sort of fixed. So sort of a basic kind of geometric drawing here, and we're not going to have to move it terribly far to give you a sense of the idea that I'm trying to illustrate. So when that end moves, I have to move this end as well. It's supposed to look like a pretty much equal amount there. So we do something like that. Bring that over. Go. Okay. I can make pretty good progress here, sort of clean up some of those old lines that we don't need anymore. And that movement that you see there along that big break through our block that represents the Earth's crust, that's what a geologic fault is. It's a break through rock mass along which movement is occurring. If it doesn't have movement like that on it, you can call it like a joint or a fracture. So get this tidied up. All right, looks nice. Now, if you were looking at this diagram closely, you might have noticed that there's kind of like a kink in the San Andreas Fault there. And the way this is set up, given the movement that we just made, that's going to squeeze together right there, right? Because of the way that the fault bends there, it's going to make the sides butt into each other. And if you have looked at diagrams of the Earth's mountain ranges before, you got big masses of rock hitting each other like that. It's going to produce mountains, right? And that is what San Gabriel's, the Santa Monica Mountains, really just about all of those transverse ranges down there in Southern California. Those are rock that's being uplifted along a bend in the San Andreas, like is illustrated here, and it's that relative sort of squeezing that is pushing the rocks up and making the mountains. So we'll kind of just draw ourselves out just a simplified mountain range here that's going to be developing along that bend in the fault zone there. And a lot of times you see something like that, you have kind of almost like a teardrop shape to the mountain range. And you'll see other little ranges developing as well, sort of sort of blending or kind of fading away into the parts of the fault that aren't quite so set up to produce, that kind of like collisional motion there, right? And you can have other ranges. The San Andreas isn't the only fault there. There's other little breakages, so you might see another little range out here or something like that. That's a little bit separated, but fundamentally the trend or sort of the alignment of that range is going to be something similar to what you're going to see elsewhere in the region. And then you'd have LA, Pasadena, all the good stuff kind of sitting down there. And you have kind of the ocean coming along, uh, like you're going to see here. I guess I should have a Santa Monica there. We'll add that in real fast. All right. So we'll have this one more kind of coastal range, just like that. Cool. All right. That's really the name of the game when it comes to those huge mountains that are looming above LA. And every time you get just a little bit of shifting movement along the San Andreas there, that's what's going to give you your earthquake. Of course, it's going to happen there miles deep, right? So this is an area that has incredible geology. It has incredible topography. Um, all of that is related to the plate movement that produces the earthquakes and also gives you the really incredibly rugged mountains, even though the land there is right next to the ocean. Now, when you got your wind coming here, it's dropping down like that, kind of over those big mountains. And it's that hot and dry wind due to the compression um, that's setting up this tinderbox scenario down there in the lower elevations that are basically downhill of those San Gabriel Mountains, right? So next time you think about LA, it's a very geologic place. There's again, really, I don't know. There's few places in the world quite like it, and as far as geology goes, how dynamic it is, it literally stands with any place on planet Earth, right? So we'll hop back to the maps now. Okay, so that's the mountain building setup, and the same plate tectonic movement that gives you the earthquakes here in Southern California also produces these mountain ranges that, when the wind is blowing from the east or northeast, produce the really hot, dry air that sets the stage for fires. If the wind is blowing from the west and blowing air from the Pacific Ocean, that moist air runs up the mountains and produces flooding and landslides on those very same mountains. So in that sense, having a big mountain range like this right next to a coastline, but also right next to a desert, is going to be a place that's going to have difficulties. It's sort of unavoidable, right? So when you see this setup here and think about those winds dropping down, interacting with all these crazy canyons, and this is going on sort of regionally here. That is that is the main ingredient in this particular situation. Now, if we were to clear those drawings away, and we'll actually kind of move the view over here just a little bit, and imagine what would happen if you shifted the winds around and brought them in off of the ocean. That color's not going to work right there. Here's that. Dark blue, too many colors. There you go. We could push air up the front of the mountains like that and produce really catastrophic rainfall. And if that happened after these fires, when all the vegetation was burned away, you're going to see more mudslides from that. Right. So again, it's just a landscape that, because of the way it's set up, where it sits with respect to the continent and the ocean, it's going to experience events that are kind of like this. Now, if you caught any of the Helene content on this channel over the past few months, you may remember me drawing something pretty similar to what I just drew there in terms of arrows showing how air masses move with respect to mountains, but over on the other side of the U.S. in the Appalachians, right? So we will zoom out again and sort of compare these scenarios. So the issue with Helene was that a low pressure system for days before Helene, and then Helene herself moved kind of like this. And so the storm went kind of up and over the Appalachian Mountains. So yeah, kind of the Appalachians would look like that. And the air masses sort of did than like you see there, and that produced huge amounts of rainfall. Okay. That was in association with low pressure system, and the low pressure system was producing this counterclockwise movement of air that was sort of like pulling that air out of the Gulf of Mexico, very moist, pushing it up those mountains and making it rain catastrophically. Now, over here on the West Coast, we'll put our high pressure right there. We'll move air around that clockwise and end up blowing that desert air across those really high mountains, making it drop down into LA, heat up, dry out, and just set up this kind of again kind of like tinderbox scenario there, right? So both of these situations are fundamentally they're the movement of air with respect to mountain ranges. And the movement of that air is what is changing its sort of characteristics. It's changing its degree of saturation or its degree of dryness, and those are the variables that are impacting both of these events. So with Helene, you had that counterclockwise thing pulling the ocean onto the land. In the case of the fires going on now, you've got high pressure clockwise movement basically bringing the desert to LA, even though LA happens to sit right there on the coast. Now, one of the big topics that you hear about with disasters like this, particularly in 2024, is what's the role of climate change in all of this? Now, we've always had hurricanes. California has always had fires as well as earthquakes and mudslides and things like that. Um, Jury, of course, is probably still out on whether or not each of these extreme events is 100% directly a result of a warming climate. That being said, what might cause like these kind of high pressures and low pressures to situate like they are and to stay fixed in a particular spot and really attack one spot with the same weather pattern just for a prolonged period, maybe like you haven't seen so much in the past, right? And that is where you have to start thinking about a jet stream. So last kind of screen annotation here, and again, I'm kind of running out of colors to use. So a jet stream, kind of a fast moving, kind of like ribbon or river, if you want to call it that, of air in the atmosphere, basically forms where the warmer air from down towards the equator meets the cooler air from up towards the poles. And jet streams, they kind of like meander around or whatever, like you might expect a river. And these kind of loops, like you see here in the jet stream, they can end up kind of making a connection, sort of like seeing right here, right? Now, that's the same high and low we drew earlier. And if you're kind of remembering where we've been here, you could end up in this way, pulling the moisture there. I don't know, I'm gonna try like an orange here or something like that. None of my colors look particularly good over there against that sort of dry southwestern US. Okay, suffice it to say, got that hot, dry air there going out to the coast, right? With a warming climate, those crazy loops in the jet stream can get more extreme, and basically they can end up being kind of like kind of like cut off almost or isolated, right? So you could have that same sort of spinning air mass sitting in one spot, sort of disconnected almost from the rest of the jet stream, and that is what could cause a given spot to be bombarded by the same wind direction and the same whatever extreme weather scenario that might be associated with it would produce for several days at a time. And if the climate warms, the way in which the jet stream makes its loops and meanders can change. So you might end up causing these either low or high pressures to sit in one spot. Another example, there was like a big heat wave in Vancouver a few years ago with about 120 degrees or something in Vancouver, Canada. That was like a high pressure that was sort of cut off and just sitting in the same spot and you couldn't get rid of it. With a warming climate, there exists the potential to chop off these highs and lows and keep them stuck and just slam the same spot for days and days and days at a time with the same conditions. Be that rain, be that dryness, you can get flooding, fires, whatever you like as a result of that. So, in that sense, warming climate, yes, could absolutely make situations like this worse. People are studying that and they're trying to determine what that connection may be and if you might expect to see it getting even worse and worse as global temperature warms and global ocean temperatures warm as well, right? So, sort of I don't know, almost like a connection between what you see out here with the fire event and what you saw with Helene. Again, they're opposites or mirror images or something like that, where with Helene you had moist air going upslope. In the case of LA, you have really dry air going downslope. They produce the opposite effects. One is too much water, one is not enough water. But at the end of the day, both of these extremes are absolutely a product of weather patterns interacting with geology, with how the landscape is set up in terms of where mountain ranges are, how elevation is distributed in the landscape, and variables like that, right? So no matter where you live, you sort of can't escape geology. And even if you're talking about weather, you might think that's totally unrelated to what's going on in terms of geology, rocks, what's under your feet. But they are very much connected, and they're very much connected anywhere in the world, right? So I hope this video is useful. Sort of a different way of seeing Southern California, maybe, and thinking about air movement at the larger scale. Sometimes you see that in the news broadcasts, but a lot of times they don't pitch that bigger picture, right? Probably going to be back on the East Coast after this one, but an absolute disaster going on in California right now. And in terms of understanding it, you have to think about how the land is set up and how the weather's set up around it, right? So hope to tune in for the next video. Hope to get another one going next week.